Good morning, listeners. Welcome to the Friday Space Show program, West Coast time, because it is still morning here. Thank you very much for tuning in, and we certainly appreciate that. I'll do a couple of business announcements at the end of the program. So for those of you on the archive listening group, don't cut off right when Dr. Stern leaves the show. I'd love for you to hear our reasons for you to support the space show, which are very important to us. But our guest today is Dr. Alan Stern. He's been a veteran of the old-fashioned space show many, many times, and of Hotel Mars with John Batchelor. And when I saw that New Horizons had woken up from a deep sleep, I thought, well, Alan needs to come back on the show. So I reached out to him. He is the PI of New Horizons and much, much more. His bio is on the website, and you should certainly check it out if you're not familiar with him. Alan, welcome back to the show. And did you sleep along with New Horizons, or were you working all the time?
David, it's great to be back. No, the New Horizons team never sleeps, even when the spacecraft gets put to bed.
So what do you do when the spacecraft is put to bed?
Well, first of all, we plan for the next active period. And we also have a lot of work to do in terms of data archiving, all the scientific data analysis, the publications, reporting at scientific meetings. And we're working on some major upgrades to the spacecraft ground system to modernize it. You know, it's now 20 years old. We want to prepare for the long haul because the spacecraft is in really good shape. Everything's working, and we have the fuel and power to run to the year 2050, whether I can run to the year 2050 or not. We're also putting up new software next year for the fault protection system that'll allow it to operate at lower power levels out into mid-century as well. So our team is super busy all the time.
Um, so why did you put it to sleep? What and for how long did it sleep, and why did it wake up at this time?
Oh, those are all good questions. I hope I can remember them all. First of all, we put it to bed in early August of 2025 last year, and it slept until late um, in June this year. So almost exactly 11 months. That's the record length hibernation. Now, when our spacecraft hibernates, it doesn't mean it's turned off. It means that some of the subsystems are turned off. In fact, we're recording scientific data from 3 instruments 24/7, even in hibernation. That goes to the solid state recorders. And then we can dump that data back to the ground when we wake it up. The reason that we hibernate primarily is because we don't have enough budget to staff mission control 12 months a year. And that problem has become pretty acute in that we now are reaching a point where we also can't afford to run some of the scientific instruments for lack of a couple $1 million a year to do all the things in mission control to do with running them and getting their data to the ground. So it's really just a budget matter.
Um, what kind of information did you pick up when it woke up? Because it's storing the data and then it sends it when it wakes up, right?
Well, there are 3 instruments that operate. One is the dust instrument. It records impacts on the spacecraft and tells us about the distribution of dust from the Kuiper Belt where we are. But it also tells us about the population of bodies that are running into one another, colliding and making that dust. And it's been producing some really surprising results. We can talk about that separately. And then the other 2 instruments are plasma spectrometers at different energy ranges that are the successors to the instruments on Voyager and are the only instruments in the sun's outer heliosphere and the only spacecraft headed to interstellar space after Voyager. And so they're learning a lot about the sun's environment and soon about interstellar space.
Did you plan New Horizons to do all of this and get this information after it went by Pluto, or is all of this new and you're sort of redirecting a new mission for it?
Um, we planned from the beginning. We put those plasma instruments on because we knew they would be valuable in the outer solar system, in the outer heliosphere. They also were valuable at the Pluto flyby and taught us a lot about Pluto's atmosphere and its interaction with the solar wind. And the dust instrument was specifically put on to study the Kuiper Belt, which we knew was dusty. And we added that instrument late in the game, and it's been very productive.
Um, so when is its next sleep coming up, and what do you expect it to do? Are you looking for any specific object, or uh, are you getting video back or just data? Sort of explain what it's looking for, what it's doing, and how you get the data back.
I think I counted 6 questions. I'm never going to remember them all.
But
Uh, um, uh, First of all, we don't have any video because the data rates are too low. There's never been any video from New Horizons. It's not capable of sending video. It has 7 scientific instruments on board. All 7 are fully operational and working according to specification. Um, and now you'll have to repeat most of the rest of your questions.
are you looking for something specific as it goes out there, or targets of opportunity?
So we do several kinds of science. One is this environmental monitoring, the 3 instruments that I mentioned that study the sun's outer heliosphere and the Kuiper Belt dust distribution. Then separately, we look at Kuiper Belt objects that we pass in the distance. And we've now studied almost 40 objects in the Kuiper Belt. And finally, we would like to do another flyby, an up-close flyby like we did in 2019 of the Kuiper Belt object Arrokoth, originally called Ultima Thule, but renamed Arrokoth. And we're using ground-based telescopes to look for that flyby target. And we've asked NASA for time on the Roman Space Telescope, which is launching this weekend, to do an even more sensitive search to get another flyby.
So you can navigate New Horizons to some degree to change it to go by this object if you find it where
Just as we did for Arrokoth, where we fired the engines to create an intercept trajectory, we can do that again. And the spacecraft is capable of doing flybys. That is, it has the power and the communications range to do flybys for more than another decade.
Do you have any instrument that lets you sort of scan ahead of the spacecraft to see any of the objects that are coming, or do you have to rely entirely on sort of near Earth telescopes to track and find those objects?
So we have 2 instruments that could do that from a standpoint of their optical capability, but we don't have enough communications bandwidth, enough bit rate to be able to send all those images back to Earth. So we, in fact, do the searches with giant telescopes on the Earth, like the Subaru telescope on Mauna Kea in Hawaii. And now we're using the Vera Rubin Observatory that the National Science Foundation commissioned this year. And as I said, we hope to be using the Roman Space Telescope.
So it's not possible for the computers on New Horizons itself to analyze the images and look for objects that are coming up?
No, in fact, we use big supercomputer farms here on Earth to analyze those images, and the computers on New Horizons are nowhere near that capable.
Right.
Uh, my question is the definition of dust. Um, how big of particles are you sensing, and what's the mass? And like, how often does a dust particle actually hit? I think it'd be very rare.
Yeah, well, I can see everybody's going to ask me 3 or 4 questions at once, and my job is to remember all of them. So the dust particles that we encounter, they have to strike the dust detector. So the spacecraft is, it's got a dish that's 2.5 meters across, but the dust counter is only about this big. It's about literally the size of what I'm showing you, and it records many impacts per month by little tiny fine smoke particle sized dust grains that weigh 10 to the minus ninth to 10 to the minus 12th grams.
That's sensitive, very sensitive.
Very sensitive. In fact, we can only use that instrument when the spacecraft is in spin mode, because the thrusters to operate in 3-axis mode create too much racket to hear um, they flood the detector with false signals.
Alan,
That's
on,
very interesting.
on Hotel Mars, we've been doing lots of shows about little red dots. And they talk about now going back to about 250 to 300 million years after the Big Bang. And they hope to go back further. But to my questions, they say that the dust that they're looking at is different dust back at that time than what a spacecraft would encounter today. So, is the dust that you're encountering, I guess the question would be modern dust, or does it go back in time to early universe, or can you tell?
Well, the dust that we see is dominated by dust created in the Kuiper Belt by Kuiper Belt objects that collide with one another. The collisions are at speeds of kilometers per second, and they create showers of dust that then spread around the Kuiper Belt. And this happens over and over again. The Kuiper Belt objects, which are the source of the dust, are the age of our solar system, 4.5 billion years old. They're not as old as the universe by a factor of 3. The dust around these red dots that you're like to talk about is closer to 13 billion, 12 or 13 billion years old. So this is neither new stuff nor primordial, but it's ancient, 4.5 billion-year-old material.
Fabulous. Joe, you want to jump in?
Yeah. You say you want to operate the spacecraft out to 2050 or something like that. Are you having the issue of getting out of radio range of the Deep Space Network?
No, in fact, if the nuclear power supply could operate indefinitely, our communication system could operate with the present day DSN out very much further to a distance of 200 astronomical units, which the spacecraft would reach somewhere in the very late 21st century. But we're
And
limited by
that
the
because
fact that
do you have more gain?
the power on board the spacecraft is from a nuclear battery,
Hmm.
which is powered itself by plutonium. The plutonium has a half-life, and every year it produces less power by a few watts. And we project that around 2050 or the early 2050s, there won't be enough power to operate the main computer and the radio system, and it'll be game over.
Yeah, because I know Voyager had this. They're still hearing the Voyager probes, and they had this problem. They had to upgrade the antennas or something like that so that they could still keep hearing the Voyager probes.
Yeah. So those upgrades helped us too. And in fact, because of our system, which is different and more modern, we could operate out even farther than the Voyagers if we had the power to still continue that long. We don't. And so that won't be a thing. We'll get out to about the distance the Voyagers are now by 2050.
Is this a case of it really comes down to the telescopes on the ground that are limiting you? Like if you built a really sensitive telescope on the backside of the moon, for example, could that telescope still communicate with beyond the anticipated retirement date?
So let me reiterate. I might not have explained it well. It's not the spacecraft telecommunication system or the deep space network that are the limiting factors. What the limiting factor is that the onboard nuclear battery will not have enough power to power the transmitter after about 2050. So it doesn't matter how sensitive the system is, can't turn it on when there's enough power to turn it on.
Oh, so it's just going to cut right out. It's not going to dwindle.
That's right.
Okay.
There'll come a day when we can't operate anymore.
Fort Worth, you have a question? You're muted. John, you're muted.
I was asked, how far out is the probe gone at this point in time?
New Horizons is presently 66 times as far from the sun as the Earth is, about twice as far as Pluto when we intercepted it.
Mhm. Okay. So,
I
so
wonder
that's, if you did have power, how far out could you receive the signal if it didn't have the power drop off due to plutonium
If we had
decaying?
the power, we're capable of communicating to the Earth as far out as 200 times as far as the Earth is from the sun.
I'd like to tag on to John's question. Now we've got three spacecraft that are leaving the solar system. I find it kind of difficult to visualize the trajectory, the path that they're taking. And I'm wondering if you could describe the path of New Horizons relative to the Kuiper Belt and the plane of the solar system, and maybe even the Voyagers.
Yeah. If you want me to take a couple of minutes, I can find a figure that would do that. But very simply, their New Horizons, only for coincidental reasons, is going basically in the direction of the two Voyagers. And that direction is towards the galactic center in terms of constellations, think Sagittarius. Not that the spacecraft is ever going to get to the galactic center, but that's the direction on the sky. Now, the two Voyagers each ended up, because of their final flybys, significantly out of the plane of the inner planets. One's going north, one's going south. New Horizons, because of its intercept with Pluto in the plane, splits the difference. So if you think of the Voyagers as one north, one south, New Horizons is right down the middle and roughly in the same direction.
Okay. And how long would it take to clear the Kuiper Belt?
You mean how long till we leave the Kuiper Belt?
Right.
That depends on how big the Kuiper Belt is. When we launched in 2006, 15 years after the Kuiper Belt was discovered, we thought the Kuiper Belt went out to about 50 astronomical units, 50 times as far as the Earth is from the sun. But since then, we found multiple lines of evidence from ground-based astronomy and from New Horizons that it goes out considerably farther. We're not sure if the belt is simply extended or if there are really two belts with a gap in between. We may learn that in the near future, but either way, the 50 that we thought was the borderline is now at least 80 and maybe still further, but we don't know yet. So we're at 66. We won't be at 80 for another 7 years or something. And if it goes even further, we'll be in it even longer.
Okay. So there's a good chance that, or some chance anyway, that you may be getting data at the time that you leave the Kuiper Belt.
I expect us to do that unless something very unexpected happens.
Great.
Are you still analyzing the Pluto flyby data, and what are we continuing to learn about Pluto? Are there any new startling updates or something that you can share with us about the Pluto flyby and information?
Yeah, a lot of people, both on our team and in the larger planetary science community, continue to dig into that data and make connections and new discoveries and do better computer modeling of the atmosphere, the interior, the workings of the planet, the geology, some things about the satellite. I'll give you an example. There's a paper we just recently published. I was first author with a team of planetary scientists and terrestrial glaciologists. And that paper makes the claim through evidence that the big glacier on Pluto, called Sputnik Planitia, this is the left side of Pluto's heart, which is a nitrogen glacier larger than the states of Texas and Oklahoma combined. We have evidence from the high resolution imaging of New Horizons that the northernmost reaches of that glacier are being wetted, presumably by liquid nitrogen produced at the bottom of the glacier and then forced up through one of a number of possible processes through conduits to reach the surface. And if I can, I'll share an image from that paper. Where's the share screen? Here it is. Can you see that figure? This is a
Yeah.
4-panel figure.
Mhm.
This is a geological map of Sputnik Planitia. Again, this teardrop-shaped region, that's the glacier. It's made of frozen nitrogen, and it's about 1 million square kilometers. So a little bit bigger than Texas and Oklahoma combined. These are images in black and white and in color of the northernmost part of it up here, where it's dark blue in the geological map. And if I enlarge this for you, and you look closely up here, I should be able to do this, yeah. These dark places that look kind of muddy, we believe are where the ice got wet. And when you wet ice, you probably know this, those of you who live around snow, it gets automatically darker. We believe that the source of the liquid nitrogen is beneath the nitrogen glacier, and it's coming up through these very narrow fissures and then spreading out away from the source conduits. And we published that paper in the Planetary Science Journal at the beginning of August. It's pretty mathematical, but it's also got a lot of good figures in it. Not just this one, this is figure 1. And if it's true, I mean, if this really pans out as we think it does, then Pluto's got liquids flowing on its surface. This is a color image of the same region. And that changes the whole game for how we think about Pluto. So that's one example, but there are lots of them for research papers that are coming out of the New Horizons data sets these days.
Pretty amazing. Which takes me back to something you mentioned earlier on in our discussion, and that is you go back to the budget process. And I'm assuming that you have to compete and fight and be heard against all other NASA projects. Uh, do you know if Isaacman favors this? I know the administration wants to cut science from time to time, and Congress doesn't let them. But how vulnerable is the pressure to cut budgets and affect New Horizons? Is it extremely vulnerable, or does it have a secure footing at
I
some
think we're
level?
pretty secure and we've been supported. We don't have enough money, as I said, to keep the lights on in mission control. That limits the amount of science that we can do. And it's coming to the point where beginning in a couple of months, we're going to have to turn off the heliospheric instruments unless NASA can get us a little bit more money, about 20% more, a couple million a year, so that we can staff mission control and get those instruments turned back on.
Is this up to NASA or Congress or both?
Both.
So if you turn it off, can you turn it back on down the road if you get
Oh
additional?
yeah, it's very easy to do. By turning it off, I don't want to give you the impression it's off forever. It's just being suspended till we have the budget to do that.
So at the time that it's off, does that mean the batteries are not being used? I mean, is that helping with the after it's back on, then there's more battery available?
Good question. First of all, we're not turning the spacecraft off. It's the instruments that study the heliosphere. They'll be turned off. So there's sensors that are being turned off, not the spacecraft.
Oh, so they don't use much power?
A few watts each.
Ah, okay. All right.
Can you explain a bit more detail why it costs like $2 million? Like why staffing on the ground at a cost of $2 million a year is needed to keep an instrument turned on? Like, and what's the mechanism by which that money gets turned into the instrument data being used or brought down or whatever?
So like every spacecraft, there's a mission control for New Horizons. And that mission control has engineers and flight controllers that operate the spacecraft and plan all the spacecraft activities and monitor the health of the spacecraft and the scientific instruments aboard. It's not very many people, but they each make a salary. And their employer charges, of course, like everybody does, for benefits, like their health
Yeah,
insurance,
but
their vacation.
what do they do? Like, what is it that they actually need to do? Like, why doesn't the instrument just stream down on? Why doesn't the data just stream down onto a hard drive automatically?
Um, so in fact, when we run the instrument, it does automatically put data on the spacecraft flash drives. That's the solid state memory. What used to be a tape recorder in the Voyager days is now flash memory on spacecraft. But in order to transmit the data to the ground, we have to operate the spacecraft using our flight controllers. That's not an automatic process. It's pretty labor intensive for sequencing that and coordinating it with the deep space network. And we don't have enough money to run the spacecraft year round. And therefore, I know this is getting complicated, but we're building a data backlog up that's unsustainable because the solid state recorders only have a certain amount of memory and then they're full. And in fact, we're going to reach a point by 2028 that we could never catch up in terms of data return, even with that budget, because the bit rates fall every year as we get further from the Earth. So, by and large,
salaries are
the
required.
bottleneck that you asked about, the budget bottleneck, Phil, is that we can't get the data transmitted to the Earth because we can't operate the spacecraft enough shifts during the year to do that. And since the recorders eventually get completely full, we have to turn off the instruments.
I see.
Now you follow. Thank you.
Yeah, I get it. So basically, it's a bandwidth problem. To get more bandwidth down from the spacecraft, you need more staffing. And to keep the bandwidth under control, you've turned off an instrument, choosing probably the instrument that adds the least value in order to keep the bandwidth down.
No, in fact, it's not the instruments. Everything you said was right, except about instruments with the least value. In fact, the heliospheric instruments are priority one, but they generate 90% of all the bits.
Value per bit, then, I guess. Yeah, the least value per
because
bit.
they're the data hogs, if you will.
Right.
Those bits are very valuable. They're the only spacecraft out in the outer heliosphere, and they have, I am not exaggerating, literally 1,000 times, 3 orders of magnitude more capability than the Voyager instruments that went through this region and preceded them. They're extremely valuable. It's just that they produce so much data that we can't keep up with it without being able to staff mission control more of the time.
Yeah, that makes sense. Thanks.
What is the transmission time to where New Horizons is today?
Well, it's 66 times as far away as the Earth is from the sun. And so you have to do the arithmetic with me. It's 66 times 8.5 minutes. So very roughly, it's something like 12 hours. But I might be off some. I don't have that number in my head. Maybe it's 10 hours.
My next question is, what temperature is this computer system operating at? I would think you're talking about, what, 50 Kelvin?
As a matter of fact, Marshall, the spacecraft was designed to be kind of a thermos bottle. And inside the thermal blankets, the spacecraft heats itself. The electronics, just like you put your hand on your laptop or your back of an old style television or whatever electronics, they warm themselves. And inside the spacecraft, it's room temperature.
Oh, that's surprising to me. So
there's no air to breathe. If you were on board, you would be in a pickle, but the temperature is just fine.
What about the RTG? Does that add to the temperature?
A little bit. It's generating about 5 kilowatts of waste heat, some of which radiates in the direction of the spacecraft and helps keep it warm. But the really dominant thing is just the spacecraft heaters and the spacecraft avionics are what keep it warm. There are portions of the spacecraft that are on the outside that are very cold, way below zero by design. But the majority of everything which is on the inside of the walls of the spacecraft is just about probably at the same temperature I'm at now and you're at now. something like 70 degrees, 65, 70 degrees Fahrenheit.
Is there any new mission even closely similar to New Horizons being planned or close to reality? And what have you learned from New Horizons that would go into a new mission that could make it perform even better than New Horizons? I'm assuming something can always be improved, but this sounds like a perfect mission.
Well, it's been very good, that's for sure. And of course, New Horizons was designed in the early 2000s, and it's now 25 years later. And so we have a lot of spacecraft technology development that you could do this even better. Unfortunately, in NASA and in the European Space Agency, the Japanese Space Agency, no one, even the Chinese, are planning another mission specifically to go to the Kuiper Belt or Pluto or other planets in the Kuiper Belt. The Chinese are planning a mission to go out into interstellar space that will have to go through the Kuiper Belt, but it's not specifically designed to do that. So I think that's a really good thing for us to be doing when we have the capability, which we have now. We just lack the money. So it's a question of priorities. And I'd like to see a return to Pluto with an orbiter, missions to other Kuiper Belt planets, and then a really thorough investigation of the workings of the outer heliosphere. Those are all good missions to do.
I know this doesn't happen, but in a perfect fantasy world, is the money too much for a private sector GoFundMe drive to fund this for New Horizons?
I don't think there's ever been a GoFundMe drive that raised hundreds of millions of dollars.
So that's what you're talking about.
Yeah, but I do think that we have the capability now in private space companies to do this if they can find a business model that pays for it.
AJ?
Yeah, I am sort of interested in the encounter with Jupiter in 2007, and especially the Jovian moons, Io, Europa, Ganymede, Callisto, etc. Although I think the spacecraft passed several million miles away from those moons, do you have any particular extraordinary things that you may have noticed or discovered? For example, Europa's, I think you saw the plume in Io with the Twestar. I'm not sure if I'm
Star.
pronouncing it correctly.
Yeah.
But that, and then in Europa, did you see anything special like water possibility, etc.?
Yeah, good questions. So as background for everybody, on the way to Pluto, we flew by Jupiter. We did it for two reasons. One was we needed Jupiter as a gravity assist. It cut the flight time from 14 years to 9. But in addition, it was the only thing we passed along the way. So it was a flight test to practice all of the software and observation techniques before it was showtime at Pluto, where we had to get it right. So we planned a very intensive stress test of the spacecraft and the instruments at Jupiter. And we conducted over 600 different kinds of scientific observations, many of them of the satellites, which AJ is talking about. And although we didn't come very close to Jupiter, a few million miles, because that's where the aim point was to go to Pluto, we have telescopic cameras that could look at those satellites. And we discovered many things about the volcanoes of Io and some things about the icy Galilean satellites. We learned a lot about Jupiter's magnetosphere, its weather systems, so forth. We were the 8th mission to Jupiter and not an orbiter like Juno is that's there now, or Galileo that was there in the 90s, but a flyby. But nonetheless, made observations of all 4 of those planet-sized satellites, the Galileans. Many scientific papers resulted from that, including the one you mentioned, which is we made the first movie. It's only 7 frames long, but it's a time lapse of that volcano, Tavashtar, spewing out into space from Io.
Amazing. Yeah. Thank you. Thank you for that information. Anything about Europa?
I'm not remembering any particular results from Europa, but that's probably because I didn't do any preparation for this call in terms of looking back at what we did at Jupiter
Okay.
almost 20 years ago. So I
Yeah,
might
right.
just be
Yeah.
forgetting.
Yeah. Okay. Thank you.
For sure. And thank you for not asking 5 questions at once.
Well, I
Even
I
the
at least
3,
covered
I'll remember them.
I at least covered 4 satellites, so
That's
4
Well,
moons.
it means you successfully passed the spatial dementia test. So look on the bright side of multiple questions at one time. What are there any surprises that you would expect as it continues going out there, or sort of a general nature of what the surprises might be, given
Sure.
found?
Sure.
What can you tell us about that kind of an
Well, first, I think we'll see great surprises when we cross what's called the termination shock and then the heliopause into interstellar space, because we have so much more advanced instrumentation than Voyager. We'll just see a lot more detail. Secondly, I mentioned the dust instrument has been producing really surprising results. We expected from mathematical models of the Kuiper Belt that the amount of dust that we detect as impactors would tail off around 50 astronomical units from the sun, 50 times as far as the Earth is. And yet it hasn't. In fact, it's been increasing. And it continues to increase. And we're now 1.5 billion miles past that point. And every time we get data from the instrument, the dust is up at this very high level that indicates that there are more objects out further that are colliding. So it's telling us about things we haven't discovered about the Kuiper Belt. I also expect that we're going to make some pretty big discoveries if we get to have another flyby, because no one's ever been to anything that formed that far out in the solar system. No spacecraft, no mission has ever explored anything farther than New Horizons in terms of a flyby. And our flyby of the Kuiper Belt object Arrokoth was 1 billion miles behind us. The next flyby will be another 1 billion miles down the road if we can find a target. And I think that it'll teach us a lot.
Jossie?
Yeah, you mentioned the Roman telescope, which is scheduled to launch, by the way, on Sunday on a Falcon Heavy. So, what do you anticipate? I mean, you're going to be using that to maybe identify targets, but it will also probably discover a lot of trans-Neptunian objects out there. It's very exciting. What are you expecting to learn from that data?
Well, the Roman's an amazing machine. And the only thing that stands between us and discoveries with Roman is getting it safely launched and commissioned. It will make many discoveries about the structure and content of the Kuiper Belt. What we want it to do is to look in the direction specifically along our trajectory and to stare for a very long time, to go very, very, very faint so that we can find another flyby target. And that's a challenge even for a machine as advanced as Roman, but it's better than anything on the ground. And it's even better than anything in space. Let me tell you some numbers. I think this will be an impressive pair of numbers to tell you. To do the search right with Roman will require about 20 days of Roman observations. If you did that with the James Webb, which everybody knows is the best thing anybody's ever launched before Roman, the same search of the same area to the same depth would take not 20 days, but with James Webb, it would take 2 years. This is how much better Roman is for this kind of thing and why we want to get time on it to find a flyby target.
Bill?
Fascinating. Your mission sounds like a photography nightmare because you're really hauling when you're going past these objects that you're trying to take photographs of. And the further away you get, the more of this R squared fall off that you get in the illumination. So, I kind of imagined that the quality of the image that we saw at Arrokoth was not as good as what we saw at Pluto. Is that true? And what can you say about the photography thing? Two questions.
Yeah. Well, we designed these instruments to be sensitive at these light levels, and they perform to specification. So it's not hard for them because they were designed to do this. And by the way, although at Pluto the sunlight is 1,000 times fainter than at Earth broad daylight, that's about like dusk. So you can read a book at dusk, you can read a book by moonlight, and the light levels even far out in the Kuiper Belt are plenty bright enough for the instruments we have, and they can operate completely to specification. And they did at Arrokoth just as they did at Pluto, and produce beautiful high resolution images. And they will at the next flyby target too. It's not a stretch for them because they were built to do this.
Okay, interesting. So the limits are really you're not approaching the limits of that.
No, by design.
Even though you're going 20,000 miles an hour or whatever it is.
35. 35,000. But remember, it's very fast, but the flybys take place at a distance of thousands of miles from the target. So, just like if you have let's say a supersonic aircraft that's got reconnaissance cameras on board, they fly over their target at high altitude and take those pictures. They don't try to come down on the deck and fly right by them 100 feet off the ground because everything would be smeared. So by the same token, when we fly by objects in space, we don't go right off the deck because it would be actually worse. It's a little counterintuitive. I'm closer, but the smear is so bad, you can't use the advantage of being close. So there's an optimal point that's as close as you can get where you keep the smear down. And that's what we do.
Gotcha. Thanks.
Joe, you've had your hand up for a while. You're muted.
Sorry. One question. What was the most surprising things you learned at Arrokoth?
Oh, that's easy. We had never been to a Kuiper Belt object, and what we knew was it would be brand new territory for exploration. What we didn't expect was that it would settle a 50-year-old debate about how planetesimals, the seeds of planets, form. Arrokoth is itself one of those seeds called planetesimals. It's as old as the solar system. And what it taught us from its geology and its shape and some other properties is that only one of the two competing theories of how these planetesimals form fit with the data from Arrokoth. There used to be a theory that things form by high-speed collisions, and there's another theory that things form by low-speed collisions. And Arrokoth is very clearly the result of low-speed accretion. And it basically settled something that had been a computer match with increasingly sophisticated codes ever since the 1960s into the end of the 2010s. And simply observing the geology and shape and other properties of Arrokoth proved that only one of the two models could work. And it's more or less taught us which path to be on to understand how planets get their start, how the seeds of planets are formed. And that was a big discovery.
Yeah, thanks.
You bet. Thanks for asking one question.
My question is, you seem to have been very interested in what the Roman telescope is going to be able to do for you. I almost presume that you had somebody communicating to them to make sure they got what you wanted on the telescope, but that implies also that 5, 10, years, there's going to be an even more spectacular telescope being launched. And what kind of characteristics do you want to see on that brand new theoretical telescope that would aid your program?
So first of all, we did not work with the designers of the Roman
Oh,
to help
okay.
New Horizons. They produced that design, and it turns out they have amazing capability to help us. But we weren't actually in on the design in any respect.
Oh,
And secondly, if somebody launches a much better telescope in 10 years, and they will, NASA's working on plans for that, it won't help us at all because we'll be past the Kuiper Belt. We will leave the Kuiper Belt. It'll be too late for it to help us. The Roman's the only shot we got. It's got this tremendous new capability, 50 times the capability of James Webb for this kind of search. 50 times. That's amazing. Imagine James Webb with all of its power as a one-story building. Then by comparison, the Roman is a 50-story building. There's just no comparison. And it's arriving just in time to help us. But whatever comes next in 10 years will be too late. We'll be out towards interstellar space at that point, no longer in the Kuiper Belt.
okay.
Alan, you launched really early before AI was a household word. I don't have a memory of what AI might have been like in its development phase back when New Horizons launched. But had it been playing an important role, would New Horizons be doing something different? Would it have made a huge difference had you had the benefits of AI in designing and maybe making it?
We're making a lot of advances in spaceflight now because AI can speed up processes and help us reduce risk by checking more things than the humans can check and check them in ways that are more thorough than a human mind can do. That would have helped. I'm sure that AI will make discoveries, and humans assisted with AI or collaborating with AI will make discoveries in the future. But at the time that New Horizons was designed in the early 2000s, there was really essentially no AI capability, and just had to use humans and computers to do computation and things like requirements tracking and so forth. Very primitive by AI standards, but we know how to make that work, and as a result, we got a spacecraft that's been out there almost 21 years and is as good as it was on day one. It is fully functional. None of the backup systems are needed because nothing's broken. All the instruments work. This is a credit to our species and to American workmanship, in my view.
Joe, go ahead.
Related to the AI question, if you were designing a spacecraft today, could you include more computer capability on the spacecraft within a reasonable power budget so that you could do some of the processing that you have to send the images to the ground to do now on the spacecraft first and have it operate more autonomously?
Probably. I'm not expert in this, and I think that the real constraint is, you put your finger on it, Joe, it's power.
Yeah.
We only had a certain amount of power. The entirety of New Horizons at launch was a power supply of 240 watts. That's 4 standard light bulbs in the United States. And everything from communications to guidance to the thermal system, the propulsion system, the solid state memories, all 7 scientific instruments, transmitters, receivers, everything runs on a combined total of what it takes to run 4 light bulbs. And if you put a lot more computing capability on board, it has to then still fit within the fixed amount of power.
Yeah, to give you an idea, I used to build data centers for Google, and that's about half of what one server in the data center takes.
So you know immediately why this is a constraint that you don't usually deal with in your business. You have infinite power in effect compared to spacecraft power budgets. Now, I think Musk is going to beat that because if he puts 1 million data centers up, they'll individually only require maybe a megawatt or hundreds of kilowatts, and he'll just overwhelm it by having 1 million little data centers that talk to each other with laser links, cross links,
Yeah.
at high bandwidth. And that's just a different architecture.
Effectively, each satellite would be roughly the equivalent of a rack in a standard data center, and then they'll be cross-linked.
Yeah, right.
John?
I'm sorry, AJ was first. Go ahead, AJ.
Oh, okay. Yeah. You had a flyby of Arrokoth in the Kuiper Belt a few years ago, something like that.
Yeah.
5-6 years ago. How far were you from? And first of all, I guess two questions. Why was it renamed from Ultima Thule to Arrokoth? That's one question. And the second question is, how far were you from this Arrokoth object, and how large or size, in terms of size, how large is it?
Okay. So let me take the two easiest, the numerical questions first.
Yeah.
We flew by Arrokoth at a distance of a few thousand miles. And Arrokoth is about 35 kilometers in length.
Oh.
That's about 20 miles.
Right.
So imagine a spacecraft, let's say that Arrokoth was Washington, D.C., which is about 20 miles across.
Right.
And we viewed it from Denver, Colorado, some distance like that, as we passed by with telescopic cameras. Okay.
It's still pretty good. Yeah.
Yeah. Mm-hmm. Yeah. What was your first question? You asked three.
Well, I think that, I mean, one question that I wanted to also ask was, are you still working with Applied Physics Lab? And is Dave Van Wee pretty supportive of this?
So the mission New Horizons is a close collaboration between the Southwest Research Institute, where I work, and the Johns Hopkins Applied Physics Lab. My institution, first, I'm the leader of the mission, so that's where we lead the mission from. That's where the staff that directs the mission is. It's where a lot of the science team is. It's also where the Science Operations Center is that operates the instruments and does all of the data processing for the instruments. The APL, the Applied Physics Lab, is where our mission control is, and it's where the spacecraft was built, and some of the science team is there as well. So yeah, we absolutely work with APL 365 days a year.
Okay, very good. Thank you.
Alan, I just read an article in Sky and Telescope on trans-Neptunian objects, and you were interviewed in the article. These are just fascinating worlds. Eris, Make,
Maki.
Gong. They're just sorry, Maki. Thank you.
They have weird names.
They do, and they have moons, they have rings, they have just a very diverse geology. It's very fascinating worlds. Which one would you like to study if we could get a spacecraft going to one of those worlds?
So I'm going to hijack your question and talk a little bit about the worlds before I answer your question.
Thank you.
So looking at the people on this call, I think you all share something in common with me. And that is, when you were in school, like when I was in school, even when I was in graduate school in the 1980s, we didn't know the Kuiper Belt existed. And when it was discovered in the 90s, we expected it to be populated with lots of things like Arrokoth and smaller. But surprisingly to many of us, we found that it was also teeming with small planets, the ones you named, like Eris and Makemake and Haumea and Pluto and Gong and so forth. We had no idea the solar system was so good at making small planets. It's now estimated that there may be 1,000 of them in the solar system. We only know of something like 15 right now, but it's hard to probe further out, and we will eventually be able to do that. But the next surprising thing, beyond the surprise of the Kuiper Belt and then that it's littered with small planets, is the fact that as we've studied and amassed knowledge about their composition, their satellites, their rings, their geology, their reflectivity, their colors, their everything, is that they are just as diverse a population as the terrestrial planets, Earth, Mars, Venus, and Mercury. And no one thought this either, that we thought, oh, they're all out there in the cold and they're born in the same stuff made far away and they should kind of be, kissing cousins of each other. Turns out they're a very diverse population. And nature always outsmarts our simple-minded ideas. And we have this amazing group of bodies. And if we could fly a spacecraft to any one of them, it would be a treasure trove. If you ask me which one, besides Pluto, I would go to next. It's a really hard question. It's kind of a Hobson's choice because they're all good. But the one that I would tell you I would pick is called Triton. Triton is actually a Kuiper Belt planet like Pluto that was captured into orbit around Neptune. It's slightly larger than Pluto and made on the outside, at least, of very similar stuff, same ices. So I would go to Triton because, one, it would teach us a lot about Pluto by seeing an analog object to it. But second, it would also allow us to see the entire Neptune system again with much better instrumentation than we had at Voyager. So by going to Triton, you get Neptune and all of its other satellites and Neptune's rings as a part of the deal. And I think that would be irresistible.
It's closer too, so less time.
It is a little closer. That's right. Good point.
Alan,
Can you say a little bit more about the diversity that you were talking about of these objects?
Say more about it?
Yeah, yeah. Like what are you seeing that's different between the different bodies?
Oh, yeah, sure. And then we're actually writing a scientific paper on this, and I've given several talks on the remarkable diversity of these bodies. Their colors are different, their satellite systems are different, their compositions are different, their densities are different. Their reflectivity as a function of angle, called their phase curves, are different. In every respect we look at them, they are heterogeneous. And in fact, if you look at the span over which any given axes of data, any given type of data varies among the known population of dwarf planets, that span is wider than the same parameter for the 4 terrestrial planets. That's what's so remarkable.
Can you tell anything about the chemical composition from the limited data we have?
We do. Yeah, we have spectroscopy. The best stuff comes from James Webb. There are several different sort of categories of composition among the dwarf planets of the Kuiper Belt. Some are sort of Pluto-like. They have these extremely volatile ices, meaning that they produce gas and therefore atmospheres and other kinds of phenomena like volatile transport at nearly 0 Kelvin. Ices like molecular nitrogen, carbon monoxide, and methane. So that's one category, the ones with the super volatile ices. Another category have lots of organic molecules. Doesn't mean there's life, it just means carbon-bearing molecules, complicated carbon-bearing molecules, and sometimes nitriles as well. And then there's a third class that just look like water ice balls that are more like the icy satellites of the giant planets. And these are just the 3 types that we've discovered so far. And several of these planets fall into each category. But when we have seen not 12 or 15 of them, but let's say 120 or 150 in coming decades, we might discover that there are more types.
Alan, before we started the show, we were testing screen sharing. You showed some pictures of your flight to space, and you mentioned that you have another one coming up. And it seems to me, from what we've been talking about today, that the space that we humans can access, including going to the moon, is so different than the space you're talking about today with New Horizons. And I know the old saying, it's space a really big place, but do you get the sense that it's a different space than what humans can access and visit and see, even if we go to the moon? I mean, trying to bring what you're talking about today into what we can personally experience is a huge, huge process, it seems, for humans. How do you do it, or is it a different space?
Well, I think it's to be a little philosophical, it's not very different in my mind than when humans first started exploring the Earth, and we were used to just wherever a given village was or encampment, and then people ranged further away and found very different kinds of places, and then as we ran into other humans, different cultures. And we went further and further until we covered the whole planet and found a lot of diversity. And, uh, you know, as different as nearer space is from the outer solar system, just imagine how tiny the solar system is compared to all the different places in the galaxy, where they're estimated to be, with no exaggeration, 1 trillion planets. 1 trillion, 10 to the 12th, 1,000 billion different planets in our galaxy alone, among the 100 billion stars. We're just at the beginning of, it's why it's called the final frontier, is we're at the beginning of something that may take humans many millennia to really get out and start exploring at these very large distances, way beyond our own solar system even. We're in the very early days of it. And I know when humans go into the outer solar system, they'll make amazing findings. And even more so when we go to planets and other stars. I am an optimist, so I think that we will do all those things in the distant future. I was very fortunate just to fly above the Earth on a scientific research mission in 2023, and going again next year. And it's an amazing experience on every level, and a very precious one these days, because it's hard to do. It'll get easier, but and it has gotten easier, or I wouldn't have been able to fly. But it's really tremendous. And I'll share a picture. Why don't I share one?
Yeah, please do.
There you go. This is what it looks like. That's my head looking at it from above, looking out the window of Virgin Galactic spacecraft on that mission in November of 2023. And you get a really unique perspective when you get a chance to do that. And you have a thrilling rocket ride at 5.5 Gs to get from the stratosphere up to those altitudes on their propulsion system. And I'm looking forward to doing it again early next year.
Alan, one of the newest tools that I hope will come online and be operational soon is a rocket with the power of Starship. How will that influence future planetary missions, or the kinds of things we've been talking about today?
Well, Starship is specifically designed to enable us to go with a very large spacecraft anywhere in the solar system. It's specifically designed to colonize Mars, to be the first really capable launch vehicle for doing that, and for doing the resupply and logistics for a human outpost, if not a city on Mars. And of course, that will enable us to go to lots of other places with humans in the asteroid belt, perhaps to Venus, certainly to do lots of things for Artemis and moon base that we couldn't do before Artemis. It's a game changer because it gets the cost down and it gets the performance up at the same time. And it's a real step change in capability. It's not an incremental change. It's a whole different ballgame with Starship. And I'm sure Starship will be succeeded by something even more grandiose by SpaceX someday, and that it will spawn competitors just as Tesla spawned competitors, and we have lots of innovation in the electric EV industry.
To keep going out and exploring where New Horizons is, do you advocate for or look forward to nuclear propulsion or some other type of futuristic propulsion rather than a chemical rocket, even a big one?
Well, we need the chemical rockets to get off the Earth. But we need to get around the solar system more quickly. We need to get around cislunar space more quickly. And nuclear is the key to that. And there are two different kinds of nuclear in very broad brushstrokes. There are fission systems like nuclear thermal, which will be a huge step forward and cut transit times to Mars from, the year class thing to a few weeks. But there are also fusion systems. And I'm actually an advisor to one company called Felicity Space that's doing this and doing it successfully, inventing propulsion systems that are even vastly more capable than what nuclear fission propulsion can do. That could take us to Pluto in a year or maybe less for future exploration as just one example. And we really need that because we're sort of in the age of sailing ships crossing the ocean when it took Columbus 6 weeks to go from Europe over here to North America, when it took Magellan a year, or was it 2 years, I think, to go around the globe. The way we've been doing space exploration in the first 60 years is you go real fast for a few minutes during launch, and then you mostly just coast until you get there. We don't continuously apply thrust. Now we have developed since the 90s electric propulsion, what used to be called ion propulsion, but it's very low thrust. So although it makes you more efficient, it's not nearly the capability of something like nuclear thermal or fusion propulsion, which will take us into the age of steamships and jet engines, equivalent for space flight. And that's when Star Trek really happens. So it's very important that
I
we
was going
do
to ask about this. So this will follow up on this a little bit more. So why haven't they used ion propulsion? Like my understanding was that the chemical propulsion with the orbit effect in very close to the Earth was very efficient, and then once you get away from the Earth and you start using other kinds of propulsion, because you no longer have the orbit effect, you're not efficient anymore. So these other technologies are fighting against the orbit effect by thrusting far away from the Earth. So are they like actually 5 times or 10 times better than chemical rockets, and so they can overcome that effect?
Yeah. The Oberth effect is not really an important factor here. It's really a question of the specific impulse which is a critical parameter of performance for these propulsion systems, that and their thrust level. And the specific impulse of nuclear and fusion systems are between 10 and 100 times what you can get from chemical. We've been using high specific impulse propulsion systems for some planetary missions, but they're very, very low thrust, fractions of a pound, whereas a launch vehicle, it will be millions of pounds of thrust. What nuclear, thermal, and the fusion systems offer is the much higher, the factors of 10 and 100 times higher specific impulse with very high thrust, like we're used to with chemical engines. So it's the best of both worlds. And that's what makes the game changer that opens the solar system up to commerce and exploration and to human settlement in ways that chemical can never do in a practical sense.
So I've never heard this of like the thermal nuclear proposals being more than like twice as good as an ISP as chemical rockets.
Well, a
Can you give us
typical
more on that?
ISP for in-space propulsion, the ISP is a
Yeah,
funny thing. It's measured in seconds.
yeah, we
And don't
understand.
ask why, but whatever it is, a typical value is a few hundred. And the ISP of the nuclear systems is a few thousand. It's a factor of 10.
So
Use your favorite AI engine or just go to Google
Like
and look it
what
up.
sort of systems are because like nuclear thermal propulsion was developed in the 60s or 70s, and it was like twice as good as It was getting like
Yeah.
900 ISP.
Nerva was about 940, something like
Yeah,
that.
yeah.
And
So
of
where are these
course, we
ones that
know
are
the
that like?
LOX hydrogen is 450, 455. So it's really just more like double rather than 10 times.
Yeah, but you're comparing to 1960s technology. Have a look at the systems that are now being developed, and you will see that they are a factor of 10, not a factor of 2.
Hmm. Can you
That's
give us some more
interesting.
insight into what systems those are, like where we would go looking for that information?
Well, take a look at NASA's development of nuclear thermal propulsion for
Yeah.
Mars exploration, and you'll find those numbers to be the case. Go to the Helicity Space website and look at what their fusion drive can do, or just go to any advanced propulsion conference, and you'll see a whole range of different nuclear implementations that have specific impulses measured not only in the thousands of seconds, but sometimes in the tens of thousands of seconds.
No, that's pretty impressive. I didn't
It
I didn't
is.
realize that the technology had advanced so much.
Yeah,
Well,
it's too
nuclear
bad we put
thermal, you're
NERVA
talking.
aside back in the 1960s. It was an amazing technology for its day, but we can do a lot better now.
Are we talking about gas core systems then? I mean, the other ones in the 60s were solid, and core, where the uranium was still solid, as opposed to having a gaseous state where you could,
John, I'm
go to,
just not familiar enough with what's under the hood in those systems to answer your question.
yeah. I mean, that'd be the way I would see you could get to the levels you're talking about.
We'll
Would be
go
if it was
research.
gaseous, then it could be very hot, and it would be, that those were considered, but I mean, nobody ever developed them for a variety of reasons. And back in the 60s, like you say.
To
How
go
do
in a
you
different.
how do you spell the name of the fusion company?
Yeah.
Because I have bad hearing and I can't
It's
make it out.
it's in the chat.
David, I
It's
put it in the
Helicity,
chat.
and
I
it's
put it in the
spelled like a
chat.
helix. Helicity,
Okay.
Helicity, Helicity Space.
Yeah, it's a problem with my hearing. So
It's in the chat, David.
It's in the
okay.
chat.
Okay, thank you. Thank you for that. We're coming up close to 90 minutes. So I'm gonna look to wind it down for Alan. So if anybody has additional comments or questions for him, now is when you should put them forth.
I'll jump
Alan,
in with one.
can you give us a contact at Helicity so that we could maybe talk to them about coming on the show?
Sure. Um, I would say that you should reach out to the company's CEO. His
Do
name
you
is
have his
Stefan.
contact?
Yeah, of course, you can email me, Stefan Lintner. But David or one of you can email me and I'll write you a connecting email.
Okay.
Thank you.
Thank you.
And by the way, there are a
Um,
number of former senior NASA officials. Myself, I ran science for NASA, but also the former head of human spaceflight, Bill Reedy, the former head of NASA Ames Research Center, the former head of technology at NASA, that are all, and the former head of JPL, that are all advisors to Helicity. Keep your eye on them.
Well, I have something I thought I could run by you. I had an idea for end of life for the Voyagers, and I thought you'd be an ideal person to weigh in on it if you're game.
I'll try.
So they're going to either run out of fuel to be able to point at the Earth, or they're going to run out of power to run their instruments. But they would probably be able to transmit just a carrier wave for some time. So when they get to their functional end of life, how about you kick them into a tumble and just let it spew out its carrier wave, and you could follow the path of the trajectory, and every now and then pick up the signal and at least know it's still there and the radios won't be silent.
That's not a dumb idea at all, Bill. They already are spinning, so you don't need to kick them into a spin.
Hmm.
The Voyager high gain antenna is 4 meters across, if I remember, and it's really a pencil beam because the RF energy is well focused. I believe that the diameter of the beam is like 1/10 of a degree, which is much smaller than the size of the Earth's orbit as seen from Voyager. So if it's pointing in one direction, it may or may not ever get the Earth in that field of view. Right now, it's actively tweaked to track the Earth so it can communicate. But once it gets to a point where we can't command it anymore and it's on its own, it's probably going to lose lock on the Earth. And I think that would make what you're envisioning hard to do, or at least intermittent.
Yeah, I'm imagining it would be intermittent, and it would only happen to cross our path,
Sure.
very intermittently. But you could still take a look in where you expected it to be and listen for a period of time to see if you pick it up every once in a while.
Yeah. Yeah. Well, I think it's a clever idea.
The fusion that you're talking about, is that also comparable fusion for grid power back here on Earth, or totally different track?
It's a different track. In fact, producing copious amounts of power for terrestrial applications is a lot harder than doing fusion for spacecraft propulsion. However, when you have a fusion propulsion system, it is capable of also being the power production for the spacecraft. So if you want to fly missions with these helicity drives that ought to be operating in the 2030s, they make their own power. And you can get rid of the solar arrays and the RTGs and all those things that we're used to, because it's a byproduct of the propulsion system, which is really handy.
You think we'll see fusion developed and become operational in a couple of years, either for propulsion or
No, not in a couple of years, but 10 years from now.
10 years?
I think it's entirely doable. I think we could have a first demonstration on orbit by the late 2020s, 3 years from now, of a single jet propulsion system, just turning on and showing it can work in space. Currently, we operate them in vacuum chambers in Pasadena, California. But a first mission to demonstrate on orbit performance could be put together in just a couple, 3 years.
Alan, have we missed anything about New Horizons that you would like to show us or share with us? Or
No, I don't think we're charging ahead and excited about the mission. But there is something else I'd like to tell you about, and that is that I'm involved with a bunch of people looking at how to fly a mission to an interstellar comet. We've now started to discover these comets that come from other solar systems and that pass through our solar system. And it's possible to do a high-speed flyby and get a close-up look at those. And that would be spectacular, because we have no hope in any of our lifetimes, even if AI lets us live to be 150. Even then, we're not going to get spacecraft to other stars in that time scale. But the other stars are sending comets to us, planetesimals, from their solar systems, and we can fly to visit them when they're close. And I think it's going to be a fascinating project and a real game changer for planetary science to see things up close formed in faraway star systems.
how do you do it?
Well, the trick is that these things come through the solar system on short notice. So you have to be ready. You have to build your spacecraft and put it in space and be ready to launch on morning, to fire the engines, to get out of Earth orbit and to do the intercept very quickly, like within a matter of a few months. And it really only weeks after discovery, so you can catch up with it. And we're putting together a system that'll do that, and that it'll have the ability with cameras and spectrometers and other kinds of instruments to really make a full exploration of the first interstellar comet to be explored by spacecraft.
So it'll be parked in space, but you may have to change orbits and go to a different part of space to run.
Well, you put it in Earth orbit, for example, or
Uh-huh.
possibly cislunar space, maybe the Lagrange points, and wait until a telescope on the ground finds something that you can go after, and then you fire the rockets to go off into interplanetary space from there.
Okay.
The
Is that a
upper stage of the
NASA
Falcon.
mission or a private sector mission? Or
This is something we'll propose for a NASA mission.
okay, AJ,
And
go ahead, Alan.
Yeah.
Oh, it's all right.
Yeah, just a question about fusion. What you will still need to use a propellant for any of the fusion or fission. Are we talking about hydrogen here
Yeah.
for fusion?
Yeah.
Okay. And the last question I forgot to ask before was that the it was named Ultima Thule in the beginning. Why
Yes.
did you change? Why was it? Why was the name changed from that
Well, when we picked the name Ultima Thule, we actually had a NASA press release, and you can go back and read it. It
Oh,
says that this is a provisional name, and it's meant to only be temporary until we see what this object looks like, and then we'll decide what we really want to call it and give it a formal name that fits within the norms of how we name objects in space. And so we always plan to just have Ultima Thule there as a temporary placeholder.
mhm.
You know, I'll give you an example. When Sedna was first discovered, a small planet in the Kuiper Belt, it was originally called Xena until we knew enough about it to get it a real name. And this is very common practice when the second and third moons of Pluto were discovered by my team,
Mhm.
the New Horizons team. They were ultimately named Nix and Hydra, but we didn't have a permanent name for them at first. And we named them Boulder and Baltimore because all the people on Discovery team were either from Boulder, Colorado, or Baltimore, Maryland. So it's very common in what we do that we give provisional names until we're
Okay.
at a place where we're ready to make a formal name. And that's why we went from Ultima Thule
Where
there.
did the name Thule come from?
Ultima Thule is, in fact, a phrase from Norse um, mythology
Oh, really?
about it's a phrase that's evocative of beyond the farthest frontiers.
Oh,
And that's how we chose it.
interesting. Yeah.
Yeah.
By
Any,
the way, being from Baltimore, it would have been okay if you left one of those moons being called Baltimore.
See if you can get that to the official naming folks.
Lord Baltimore.
There you
Any
go.
closing comments from anybody? Or Alan, do you have anything else you'd like to leave us with?
Well, I just want to say that this new format where you've got a dozen people firing questions is a lot of fun. It's challenging, but I really enjoyed it.
Well,
Thank you
that's
for
good. Again,
having me, David.
it's an anti-dimension program for dementia for those of us getting older to keep up with it. But thank you, and we'll do it again. When does New Horizons go back to sleep?
Next June.
Does writing letters to these budget processes and stuff help, like keep New Horizons funding going? Or
You know, it never hurts. It never hurts. And actually, I'm told by people on Capitol Hill, they almost never get letters anymore. They mostly get emails. When they get 5 letters, they think that's a big deal because it used to be you could drum up 1,000 letters for something, but no one sends mail anymore.
well, yeah, I can understand why. I paid my CPA and we're into the 20th day, Las Vegas to Las Vegas, and the mail still haven't delivered it. So,
Yeah, well,
um,
and in Congress, you might remember in 2001, the same year as 9/11, there were these packages with white powder sent to Capitol Hill that spooked people. And so now they have weeks of delay in getting all that, anything that's sent as hard mail, checked out and sniffed out before they
Yeah.
expose people to a potential terrorist danger.
because I'm sure all of us here would absolutely support New Horizons, so we should communicate that to them. So, um,
Yeah.
we thank you very much for coming on board and for all of you from the space show who joined us. Also, thank you. And for the archive listeners, remember we're listener funded 501c3. So please do support us. And PayPal is on the Space Show website at spaceshow.com, upper right corner. And Substack uses Stripe within their own programming. So if you like these kinds of programs, help us out. Alan, until the next time, and hopefully you can make it to Hotel Mars soon.
I
And
sure plan to.
I will talk to you or elsewhere about it. and keep it up. It's very, very exciting, and it's great news in a world where great news is sometimes challenged. So
Thank you again for having me, David, and thank you all for the great questions.
Thank you for allowing us to do that.
and
Thanks, Al.
And sometimes multiple questions at the same time.
and listeners, everybody have a great weekend. And once again, thank you, Alan.